Welcome to this edition of the Open Slider project by DIY3DTech.com. In this episode, we're going to be continuing the instructional build process of assembling the rails and the basic slider mount. So now in this episode, we're going to be taking a look at the stage or slider itself, and I'm going to do this a little bit differently. So in the first two, we've covered out the ends. We've covered out in the second piece the mounting bracket here. So obviously in this third piece, we're going to talk about the stage or slider here. To do that, I want to do it a little bit differently because when we get to the stage or slider, there's a number of different options. So one of the primary options, obviously size, also the type of wheels. So you'll notice that this one uses the maker wheels, whereas this one uses the 608ZZ bearings. So let's talk a little bit about those pieces first, and then we'll kind of get into how this all really works. So with the V-slot wheels, these are basically like a Durland plastic around a bearing. And these are pretty nice, and these are a nice way to go. The only thing with these are about $4.50 a piece. Not a huge amount of money, so you're looking probably at pretty close to $20 for this stage. Whereas the 608ZZ bearing, these are probably about 50 cents a piece. So you're looking at roughly $2. So $20, $2. Now, one of the things, again, the maker rail is aluminum. These are metal, so when you do this, you are running metal against aluminum, and I wouldn't suggest this for a machine type action. However, for the use of a camera slider and the cost of all this, I would not worry one bit about metal against aluminum. And as you can see, what happens is with all scenarios, they run inside the track of the maker rail. Now, all these, platforms are sized to the various wheels, and actually, while this one is fixed, these can be adapted to go either way, because you notice the slots here. So these are sort of ambidextrous when it comes to these versions. Same thing with this one. You notice that I have built the slots in here, so if you wanted to, you could actually turn this and readjust it so your slider is the long way. So it really gives you a lot of flexibility in how you want to go. And this is part of the reason for these two here, because you could also do it this way. So there's a number of different ways that you can actually assemble these. And so that's the second part that I want to get into talking about. Well, before I do that, I do want to point out also 3D printed versus laser cutter CNC. So this one I cut out on the laser cutter. This one I cut out, I printed on the 3D printer. So again, I've got them out there, and you could CNC this one too. So doesn't make a difference, laser, CNC. So I wanted to make this so no matter what type of tooling you had, you could make one of these, 3D printer or laser or CNC. Now, in full disclosure, you really sort of need the 3D printer if you want to be effective and combine the two, because one of the things you'll notice with this one, and this is what we're going to get into in a second, is the standoffs here. These are very important. Now, these were 3D printed, so as part of this, instead of actually building one, I'm going to take one apart and show you. So I'm going to take a wrench here, and I'm just going to remove one of these wheels and show you how this all goes together. Oh, that's on there further than I thought it was. I think that's off. Yep. So let's take that bolt off. These are, I believe, a number 8 bolt that I've used. This might be a little bit harder than I thought, because that might be threaded on there a little bit better than I thought. I might have to put a little bit more pressure to kind of unthread this. I probably cut this part. Okay, so here's how this works. So, and this in short works the same basic way for either the V-slot wheels or this bearing, because inside this bearing in here you have a race. And this race is what stays stationary, and the wheel spins, or the outer race spins around it. And obviously behind this little retainer ring is a bunch of ball bearings. And so what has to happen is we have to have a standoff. So the way that this is situated, and these are out on the website, by the way, is this outer piece. So you see it's staged. So you get a thick piece. Here you have a thinner piece and you have a very thin piece. Now what happens is the very thin piece goes inside of this, and this middle tier piece sits on this race like that. So the wheel's allowed to spin. And then what's happening, I don't know if you can see kind of in there, so there's a little bit of space. Now there's a counter piece that's almost the same way, except it doesn't have the big piece for the standoff where it'll slip in there. Now this one, because it's a little bit tight, is kind of screwed in. However, the same thing applies. So as you see, it rests against the race, and you can see it's a little short of being proud of the race, and it sits inside there, and that's what gives us the ability to turn inside the bearing. So this is very important, because these are I'd say semi-precision design. So there's a pretty low tolerance. Now the piece is these are spec'd. I spec'd when I designed these for a number 10 bolt, but what happens is, depending upon the plastic you'll print these in, they will come out as probably a little bit smaller. So you can drill them out or ream them out for the number 10s, or you can just put number 8s in here, and that's what I've done in this case. You can go down all the way down to number 6, because one of the things to keep in mind about this is, once you put these two pieces on, and then you put a bolt through here, even if I were to use a number 6 bolt, it would probably work just fine too, because you're pulling these together and they're going to pull themselves semi-true. The only difference might be is how much play you'll have inside the slot here when it goes on to the rail here, like this. So you might have a little bit more play. Now these, I designed these to be pretty tight, so there's a bit of movement. And one of the things that you'll notice with the metal bearings versus the plastic wheels is the noise. There's noise with both. However, there's a little bit more with the metal. Yet when you're doing a slider action with a camera, typically it's a time lapse or something where you're really not so much worrying about the direct sound from the camera. You have a separate type of mic, so just be aware of that. But they all do produce some sort of sound. The metal's a little bit more. And you notice I've got 3 on here now, and this is the thing. You can put multiple skates or stages on a rail, so it doesn't much matter, and you can sort of mix or match as far as putting them together. And then, after you have what you want on here, you can take the end and just spin it back on. And again, one of the things that this does is stops it from going over the end and your camera running off. So that's another purpose for these, other than mounting to the tripod. So even if you don't decide you want to do a dual tripod mount, like we talked about in the first video, this is still an effective means to keep your camera from going right off the end. There's a 1/4 20 bolt here, and this allows us to attach different mounting brackets to it. So you can just kind of screw on this mounting bracket, or you can use and I'll talk about this a little bit more in other videos. You can use a stand-up stage on here to elevate it, and then do something like that. You can do get more economical and just take, for example, like a 1/4 20 pressure fit, and then screw that on there like this, and then put your camera on top of this. So there's all kinds of stuff you can do, and I'm just kind of showing real quick here. And again, this is really, you can see for the GoPro style cameras, you know, this is what it's really meant for, is that size and weight of camera. So anyways, I think I covered out that part, so do that. And then again, we'll talk about in a future video in the series about, you know, different type of feet. I designed these feet. I've just got these stand a little bit proud, but the idea is these would mount to a board or a desk or something, or more stable structure. You know, these are feet. So we'll talk about different mountings if you don't want to use a tripod in future videos. We'll also get, as I mentioned, a little bit more into, you know, maybe some additional stanchions and things like that. Also, if you have some ideas or comments, hit me up down below of what you'd like to see designed to add to the portfolio of different components for this. I do have some other basic ideas. For example, one of the things in the future video, I will be adding motor drives to these. So the motor drive will mount on the side here. And the piece is this is where I want this to kind of be, you know, one-stop shop. So you'll notice that, you know, I've built in belt connections here. So in short, you use a small number 4 screw to kind of bolt this in, loop it through, and you just take a, you know, I've got a laser cut piece or a 3D printed piece that'll go over here to clamp this down. And then what will happen is a G2 belt will pull the stage back and forth across the rail. I will do some stepper motors. I'm going to start with a 12 volt DC geared motor because it's cheap, easy, and it provides a lot of torque over top of the stepper. Now, I mean, just kind of give you a little bit of teaser. I mean, the difference, you know, if you look back in some of my other videos, especially on the parent channel over here, I've done some stuff with stepper motors, but especially in such a short distance or throw as this, you do get a little bit of jerkiness, which I didn't like. So this is why I decided to, whoops, I think I knocked you around. That's why I've decided to kind of try this route to see if I can't smooth it out. Especially for shorter time lapses, you really notice the jerkiness. And so since this is an analog device and it's a continual pull, I'm hoping that takes the jerkiness. But a little teaser for the future. So anyways, hopefully this explained how this goes together. Now, all these can be found on our site. All the STLs or the SVGs, etc. can be found out on our site. So if you want to build one of these platforms, go out, take a look at our site. Links down below to the website, openslider.diy3dtech.com. So it's just a prefix on this over here. And again, hopefully you found this interesting. If you did, give it a thumbs up. It helps me make more of these. And subscribe to the channel. Be a lot more coming because, again, hopefully I'll do another series where we talk about how to use these in different things. And again, I'd like to get your ideas. So comment below, and we'll see you in the next video. Cheers.
Please click like below and subscribe to the channel to keep up to date on all of our projects.